Learning math as a skill is truly something that can benefit us in our lives. Learning how to use our money effectively and calculating the food we need for a party are just two ways math can help us in our everyday lives. Lessons such as trigonometry, statistics, and algebra are just a few of the lessons that can help us with the jobs that we would want to take when we are older. One lesson in particular, graphing, more specifically the systems of linear equations, is what we'll be tackling in today's video. My name is Nico Nathaniel Esolfanta, and in today's video, we'll be talking about the types of systems of linear equations, what they are, and how each of them work. Let's get into it. There are three types of systems of linear equations: the consistent independent system, consistent dependent system, and the inconsistent system. The two aspects of a system of a linear equation that differs each type is the m or the slope and the b or the y-intercept. The first one, the consistent independent system, or CIS for short, is a system that has only one solution. If their graphs only have one point of intersection, then the system is consistent and independent. That is, if the m1 and m2 do not have the same value. An example of this would be y equals 2x plus 1 and y equals x plus 4. We know this system of a linear equation is a CIS because the slope value, or the number right next to the x, is not the same in either equation. Another example of a consistent independent system would be y equals 3x plus 4 and 3y equals 6x minus 15. This system of a linear equation still counts as a CIS because if we solve the second equation, their slope values still won't match. Next, the CDS, or consistent dependent system, is a system that has an infinite amount of solutions. Their graphs are in the same place. If both the slope and the y-intercept for a system of linear equations are equal in value, then they are a consistent dependent system. An example of a consistent dependent system would be y equals x plus 1 and y equals x plus 1. This system of linear equations is a CDS since it is easy to tell that both the slope and the y-intercept values are the same. Another example would be 3y equals 9x plus 3 and 2y equals 6x plus 2. When we solve both of these equations, we get two equations that have the same slope and y-intercept value. Therefore, they are a consistent dependent system. The last one is the inconsistent system. A system of linear equations is inconsistent if it has no solution. Their graphs are parallel. If the m value of a system of linear equations is equal while its y-intercept isn't, then it is an inconsistent system. An example of an inconsistent system would be y equals 2x plus 14 and y equals 2x plus 38. This system of linear equations is an inconsistent system because it fits the requirements necessary for a system to be an inconsistent system. Another one would be 5y equals 10x minus 25 and 2y equals 4x plus 4. When solving these equations, we can see that their slope values match, but their y-intercept values don't. So we can safely say that this is an inconsistent system. Now that we have tackled the different types of a system of linear equations, we can now figure out how we can find the types of system of linear equations in a problem. Firstly, we need to turn both equations into a slope-intercept form. That way, we can easily figure out the values of the slope and y-intercept to determine what type of system of linear equations they are. Note that our y variable should not have any values right next to it. Next, we find out which type of system of linear equation the two equations are by checking which of them they best fit in, based on their slope and y-intercept values. Thanks for watching my video. I hope you have learned a thing or two from my video presentation. My name is Nico Nathaniel Esolfanta, and again, thanks for watching.